And let's go ahead and we're gonna start talking about wrapper classes. So wrapper classes are basically a way of wrapping a primitive variable into a class and making it basically an object. So let's kind of review what our primitives are. So let me get my annotation tool. All right, so primitives. So primitive data types are things like our int, which is our whole numbers, doubles, which are decimal point numbers, and we also have, let me make that bigger, Booleans are primitives. So this is true, false. And we've also covered char, which is short for character, so single characters, which, you know, I kind of want to add that that's not on the AP test. Okay, so we've got these primitives, and primitives are a bit different than objects. So let's talk about how they differ. So we also have objects, which are called reference type variables. And so reference type variables are things like, these are instances of classes, right? So any class that you create, like we've created like the rectangle class and we've created objects from that. But there's also things like strings that are kind of like inherent to Java, where you don't create that class, it's already a part of Java. So strings are a reference type. So what makes these two things different? Well, one major thing that makes these two things different is the fact that when you create a primitive in memory, that named space, so say like I created an integer called number, that named place and location actually holds the value at the same place where the variable lives. So say like I created int number gets 5, that means that the value actually lives at that physical location in memory. If I create an object, a reference type variable, we kind of are a little bit familiar with, you know, diagramming this, where we have like the reference variable. So let's say we created a string called text, but the value doesn't actually live at that named place in memory. We actually, the reference variable points to where the value lives. So it would point to another place in memory here. So like, let's say that it points to a string called with the value of high. So that's not like groundbreaking or anything. What's more important is that these objects or reference type variables, since they're members of a class, they actually have methods. They have methods available to them, right? So you could call methods on them. They also have member variables or instance variables. We've been calling them instance variables. And these are, in other words, kind of attributes, attributes that kind of define what it means to be a member of that class. Okay. Now primitives are very, very simple. They don't have any methods associated with them, and they don't have any additional attributes. So you can kind of think of classes as being like these more complex members of Java, right? They have a lot more data. They could potentially have a lot more data associated with them because they could have multiple instance variables, and they can also have methods that you can call on them. primitives are very simple. They just have a single value living at a single address in memory. Okay, but sometimes we want to treat these primitives as if they are objects, and that's when the notion of wrapper classes come into play. So we're only going to really cover the wrapper classes for integer. So yeah, that. So wrapper classes. For integer, that wrapper class, guess what? It's just integer, but it's with a capital I. So classes in Java always start with a capital letter. And so for integer, that is integer, right? Just with a capital I. And this actually gives you access to member variables and methods that belong to the integer class. And then you can probably guess that the wrapper class for double is actually just double with a capital D. And again, this will give you access to member variables or instance variables and methods that are associated with this double class. Now we've already seen a couple of examples of instance variables associated with the integer class in a previous lesson. So those were integer dot max value, which gives you the maximum possible value that an integer can have. And it also included integer dot min value, which gives you the minimum possible value that an integer can have. Okay, but today we'll take a look at some methods that are also available to us in the integer and the double classes. All right, so let's go ahead and dive into some of these examples to actually see how this is, see examples of the methods being called and stuff like that. So I'm going to go ahead and clear my screen. And we are going to get rid of that so I can click. All right, so creating integers. Okay, so just like in the previous lesson, they do link you to the documentation for the integer class. So I'm going to open that up real quick. I'll have that open in a tab just so as it comes up, we can look at that. So let's explore this example. Okay, so usually we are used to declaring an integer in this way. So int x gets, and then like 12, for instance, right? Because it's a primitive. So this is the primitive version. But you can also create an integer object in this way. So you're kind of used to instantiating objects in this way, where we put the name of the class, a variable name that of our choice, and then we use the new keyword, and then this is the constructor. Okay, and so the constructor is going to take in the value that we want the integer to be. Okay, so it's kind of doing the same thing. We're creating an integer with a value of 12, but this is actually creating an object type of integer so that we can have access to the integer methods and stuff like that. Okay, down here, notice that there's no call to a constructor, right? So here's a call to the constructor up here. But down here, we are declaring it of a integer object type, right? Note the capitalization of the I here. We give it a variable name of y, but notice how on the right-hand side of the equal sign, we're treating it as if we're assigning it a primitive value. There's no call to a constructor here. But even though we're doing that, Java helps us out. Java helps us out with something called auto boxing. So even though this 12 is a primitive value, a primitive integer value, Java will actually secretly behind your back actually do this. It'll create an integer object for you. And the reason why that is because on the left-hand side, we are saying, hey, we want an object integer, right? We want an integer object, not a primitive. So this is called auto boxing, turning a primitive data type like int into a reference or object type, like integer with a capital I. Okay, so this again is called autoboxing. And then the opposite of autoboxing is called unboxing. So we can actually convert an object type variable, a reference variable, back into a primitive type. So we can convert integer to an int. And that is actually happening here. So we are actually, we're printing out objects, and usually we need to have a toString defined in the class in order to do that. But if we look at the class, there actually is no toString defined. There's a toString defined, but we're not calling it explicitly. And so what it's actually doing is it is unboxing this variable back into a primitive so it could be printed as if it were a primitive. Okay. Down here, there's some examples of methods that you can call on our integer objects, because remember, x and y are both integer objects. And because they are objects, they have access to methods that live in the integer class. So let's go ahead and let's take a look at this method right here. So I'm going to go to my documentation, and I'm going to say int value. Okay, so if we call int value, it's going to return the value of the object integer as a primitive int. So it's going to just give us the value, the number. Okay, so going back here, we want to calculate the sum of these two objects, and we do that by explicitly calling int value to get the number. So let's see, x pointed to an integer value of 12, so this is the same thing as doing 12 plus, and then y was also 12, yeah. So it's the same thing as getting 12 plus 12, and you're probably thinking, wow, that's really complicated for just getting 12 plus 12. They're really just doing this as an example, though. There are reasons that you might want to do this, but that's kind of beyond the scope of the class. They just kind of want to give examples of you having access to methods when you convert a primitive like integer, the lowercase, to an object type integer with an uppercase. You would also have direct access to that toString that I mentioned. So you could actually call that on the object itself to get the string version of the value so that you can concatenate it in a sentence. And so you could actually, yeah, print out the equation here. Let's see, what else? You can use integers exactly like you can the primitive versions because of unboxing. So Java is actually very smart in realizing when it has to autobox into an object if you want to convert it into a reference type, and when you want to unbox it so that you can do things like basic arithmetic, like subtraction, multiplication, addition, and division. So let's go ahead and run this code and let's kind of see what's going on. Okay, so looking at this line right here, we are printing out the value of x. And what's happening here is we're unboxing the object into a primitive type so we could just display the value. And then what's happening on line 26 is we're doing the same thing with y. We're doing unboxing so we could just display the value of y. And then let's see, on line 34, we're printing an equation, which is the result of lines 32 and 33. So we're converting the value of x to a string. So this is, let me add a comment. So this is creating the string version of x, which is 12. And then we're concatenating a plus symbol. So it's going to look like that. And then we're concatenating the string version of y, which also is 12. And then, so we have that string. But then we say equation. This is the same thing as saying equation gets equal sign plus whatever the sum is. So let's see, where's the sum? Sum is up here. So sum we said was going to be 12 plus 12, which is 24. Okay. All right, so like I said, this is the same thing as equation gets, sorry, it should be equation plus this equal sign and then plus 24. So when we evaluate all of that, it's going to be the string 12 plus 12. So 12 plus 12 was coming from here on this line. And then an equals symbol, so right here. And then this final number here, 24. Oops, 24. And that's what we get right here. All right, and then similarly, we do the same thing with this chunk of code, and that's how we get the equation formatted in a string this way. Okay, so let's, for the sake of time, I'm gonna go to now the double example. So it's gonna be very similar, it's just gonna be with double values. Okay, so similarly, they link us to the double documentation for the double class. And you can notice that you can create a double object, basically in the same way that we saw for an integer. So this is creating a double object with a value of 16.8. And then again, auto boxing will happen if you explicitly say, hey, I want a double object, but then you only pass in the primitive value. So this is going to actually creates an object, creates a double object with a value of 20.2 for its private instance variable. Okay, so again, auto boxing is when you pass in, when you give it a primitive value, but you explicitly say you want an object. So it's automatically going to take this value and then turn it into an object type or a reference type. And okay, so down here we can see kind of like a similar example as we saw with the integer class. So we could use doubles exactly like we can with the primitive type double because of auto boxing. So if we try to print out the value of this double, which is x, we will just get the value that's actually being stored inside, which is 16.8. So if we print that out, so we go ahead and we see the value, it works as normal. It works just like we were using the primitive. And then same thing here, we can actually explicitly call the double value method to actually get the value of y as well. It works the same exact way. So there's no reason why you would actually want to explicitly call this. If I got rid of that method call, it's actually still gonna do the same thing. And that's because of auto boxing and unboxing. So let me put that back. You could also cast. You can cast things as well. So, you know, even though x is an object, you can still cast it to an integer primitive. So notice how here's the casting operator where, hey, I want the value to the right of me to be a primitive integer type. And then here's the actual double object value. And then we're casting it as an integer and storing it into this variable here. And then this last line here just prints out the double as an integer. So since this x value was 16.8, that means if we cast this to an integer, we're gonna lose this decimal point and everything to the right of it, and we're just left with the value 16, which is why we get that here. All right, last example. is going to be autoboxing. So let's talk a little bit more about what autoboxing is. So autoboxing, again, is when we have a primitive value. So autoboxing is the automatic conversion of a primitive into a reference type. Let me put that on the next line. So object. Okay. Okay, so here we have some examples of variables, right? So here we have an object type, right? This is a double object. We're passing it a primitive value. We're not calling the constructor. But because of autoboxing, it automatically just calls the constructor for us and creates a double object with this value. Down here we have, this is a primitive. And if you ever forget which one is a primitive and which one is an object, remember that objects are always members of classes and classes are always capitalized. Primitives are always lowercase. So this one right here is also a primitive. Primitive, yep. And then line 13, we see a capital I, an integer, so this is an object. Even though we are not calling a constructor, right? We're passing in a primitive value. We know that Java secretly behind our back goes ahead and calls the constructor for us and passes in this value to create an object for us. Now, why the heck do we want to use this autoboxing and wrapper classes stuff? That's because some methods and some data structures, we haven't gotten into data structures yet, but we will second semester. Data structures like array list, so we've got something called array list, is a structure that only holds objects. So there's going to be times when you're going to want to hold just regular values like whole numbers and decimal numbers. And you're going to want to hold it in an array list because it can hold a whole list of these things. The problem is that since an array list can only hold objects, is we can't hold primitives, right? We can't hold ints or doubles at all. And that's where this autoboxing thing comes into play, where we can try to, assign a bunch of ints and doubles to the array list. And what will happen is autoboxing will convert the ints that we want to store into an array list as integer objects. And doubles that we may want to store inside of an array list as double objects. Okay, so that's why it's important. I know it's a little annoying that we're kind of covering this before we actually cover array lists, but that's just how the College Board has kind of structured the class to kind of cover this stuff now. But really, you just need to kind of understand that this stuff kind of happens under the hood. Java really does all the work for you. You don't have to explicitly, create objects or anything like that. And you don't have to explicitly convert primitives into objects. It just kind of happens automatically, hence, the term autoboxing. Okay, so yeah, notice that we can still, even though this method takes a double object, we can still pass it a primitive because of autoboxing. So this is a primitive, this light percent is a primitive value, but what's going to happen is it's going to actually autobox it as a double object so that this code still works. Down here, this method, set squat, takes a primitive double, but we can still pass it an object type of double, and it'll unbox it for us to the primitive type. So really, like I said, Java is going to do all the work for you. You just have to understand that this is happening in the background. And you don't have to explicitly say, hey, I want to convert this object into a primitive or convert this primitive to an object. It just happens for you. So it may be confusing at first, but once it kind of like clicks, hopefully it will sooner than later. But there's just 3 different homework problems for this. And if you haven't already, watch this video as well, take the quiz, and then tackle these 3 assignments. And then, like I said, on Saturday, I will release a video that kind of goes over how to solve these. And the homework for this is due on Sunday. Now on Friday is our office hours. That, again, as a reminder, will be when we review the multiple choice questions from the Unit 2 progress check, Part A. And then Monday, we'll do the last section using the math class. We'll review the homework that following Wednesday. And then you'll have Wednesday till Friday to finish the Unit 2 progress check in preparation for the test, which will be November 4th, and then due November 6th. All right, any questions? All right, I'm gonna go ahead and stop recording.